This is my video proof that the limit of the sum of functions is going to be equal to the sum of those limits. All right, so we're just going to go ahead and say the limit of f of x as x goes to x naught is going to be equal to a. And similarly, we're going to do the same thing with b, or with g. We're going to have the limit as x goes to x naught of g of x is going to be equal to b. So given epsilon over 2 greater than 0, we like epsilon over 2 here because it works really nicely with our algebra. There's going to exist a delta 1 so that if 0 is less than the absolute value of x minus x naught is less than delta sub 1, then the absolute value of f of x minus a is going to be less than epsilon over 2. And there also exists a delta 2 greater than 0 so that if 0 is less than the absolute value of x is less than delta sub 2, then the absolute value of g of x minus b is going to be less than epsilon over 2. So this is just our definition of limits of a function. So we're going to go ahead and set a specific delta we want here, though, for this proof. We're going to go ahead and say that delta is going to be equal to the minimum of delta 1, delta 2. And we'll say that 0 is going to be less than the absolute value of x minus x naught less than delta. All right, then we're going to have the absolute value of f of x minus f of a is going to be less than epsilon over 2. And we'll also have the absolute value of g of x minus b is less than epsilon over 2. Both these hold based on our delta being smaller than than either of the other deltas. So both of these things have to be true. Okay, well, we can just sum all this together. So what do we get? We get the absolute value of f of x minus a plus the absolute value of g of x minus b. And that's going to be less than epsilon over 2 plus epsilon over 2. Some nice things happen. As you can see, the right side is just going to become epsilon. But on the left side, though, we can use the triangle inequality and say that we can say that the absolute value of f of x minus a plus g of x minus b is going to be greater than, and I'm kind of talking backwards here, but all this is going to be greater than the absolute value of f of x minus a plus g of x minus b. So now we can actually go ahead and cut this middle part out since all we care about is the epsilon in this far end. And with just a little bit of moving around of our minus signs, we end up with the absolute value of quantity f of x plus g of x minus the sum of a plus b, which, hey, all that's less than epsilon, but that's just the definition of a limit because epsilon's arbitrary. We can make epsilon as small as we want to, and we can find a delta. So the limit of f of x plus g of x as x tends to x naught is equal to the limit as x approaches x naught of f of x plus the limit of g of x as x approaches x naught. QED.